Okay, we are back again to work on our switching regulator buck converter lab. So this one is kind of a small deal, so it's not as bad as making libraries and some of the other ones. All we have to do now, here's our chip that we're working with. All we have to do today now is get this typical application circuit into KiCad, into the schematic editor. Okay, so it's going to be pretty basic. We will have to make this one symbol right here. Most of the rest of the stuff we should be able to find in the default stuff. Okay, so that's our task. Now there's a few things, some things on here that we're going to end up changing, and there's something, at least one thing that I found that I'm going to change from what I've said in the previous videos, if you watch those, which you should be watching. So this is kind of like a little series in order. But we're still just going to mash this into KiCad right now, and then we'll make the mods after they're in there, okay? So I think that that's kind of the best way to get started. Now, I wanted to point out something that I didn't notice before because I didn't entirely RTFM. I didn't scroll all the way down to the bottom. You know, get past all the charts and the graphs. Sorry, I'm kind of zoomed in a bit. Get down here further. Block diagrams and all the chip definitions and everything like that. Kind of assuming as I was getting down here that towards the bottom I'd have the footprints that we get to later when we get into the PCB editing and such. But look at this. What I didn't notice, and I think that this is really cool, is that they are telling us very specifically how to lay out this board. I did mention this in the other videos that I thought it was cool that up above, further up there, that it did mention, you know, things like, you know, keep trace width is so far, width wise, and also keep, you know, certain like decoupling caps very, very close to, you know, sources and such, right? But they go so far as to give you an actual idea, kind of like a typical PCB layout, if you will, right? Recommended PCB layout. And this is fabulous. I think this is great. So we're going to end up probably copying this fairly verbatim when we get into building our board, all right? But then if you come down here a little bit further, there's two more, well, sort of one more, typical application circuits. It really doesn't change anything, but it did kind of clue me into one little bit. So I was dwelling over this output cap over here being an electrolytic because that just sort of seems to feel like what it normally would be. But they're actually saying right here, here's the typical application schematic if you're using ceramic output caps, okay? The other one down here is for the POS cap, the tantalum style caps of sorts, specific ones. And there is no one down here for electrolytic, so that was my clue in that they did actually mean ceramic. And so now that kind of helps. In the other video, I was kind of dwelling on the fact that I could not find an 88 microfarad cap, and I was looking kind of specific, and there was kind of like some weird, you know, costs, etc. and kind of talked about that a little bit. But what we're going to do instead is we're going to take this, and instead of going with the 100 microfarad that I did get, that probably would be fine, just to get our 88, and hopefully this will work out okay, we're going to go with 4 22s. Why? Well, because 422 is 88, and that's kind of a nice clean number, but really it was because when I went to DigiKey, that's the ones that I could find. So basically you just go in there and start looking for, do they get 88? No. Do they have half of 88? Do they got like, could I get 8 10s and an 8, you know? And how could I add this up in parallel to get enough that I could have 88 microfarads for a bypass, okay? Then the other thing I just noticed as I was doing that is I looked over here, and look at that. Isn't that convenient? This is also 22 microfarads. So if I got a whole bunch of 22 microfarads, you know, right for this voltage over here, and you could still use it over here, then hey, looky, we got a pack of those. We don't have to have multiple different types of components. Reducing your bill of materials. Excellent. Okay. So, I guess that's really it. On with the biz. We're just going to get this in here. So this one right here is the main one, the same one that was up here at the top, okay? So I'll go ahead and move this out of the way, and I will make a picture and put it up here so you can kind of follow along. the first thing I need to do, I feel, is get the chip made. Because again, all the rest of the stuff is going to be the plain old components that we're going to find in under all the passives and crap. I just need to make the chip itself. So, as usual, you have to tell it which library you're working in and see the previous video if you don't know how to make your libraries or put to select your library. We're just going to go ahead and go past that. We're going to go up here. We're going to pick create new symbol, edit new symbol. And we're not going to edit one that already exists. We're not going to make a new library or anything like that. We're just going to go right here to create new symbol. When you hit the create new symbol, it will ask you which library do you want to store this in. So we want to store it in our library that we made previously. And we'll hit OK. And it's going to ask you for a name. So we got to come up with a good name for this. And I think that, NB, well, let's see. Hold on a second on this. Do we really want to call it NB679 or do we want to call it Buck NB679, right? So something that maybe is going to clue us in when we're looking through the libraries. When we're in our library, we're looking through all the components and we're looking for something, I need another one of these. Is this going to jump out at us as the NB679 name, right? So I'm going to call it NB679 Buck underscore NB679. The default reference designator, we'll leave this as U. U is for ICs. Hold on. Here is the Wikipedia for reference designators for schematic circuits. So if you scroll through here, look this up. This is all the values, the designators for the different types of things. Q for transistor, transformer T, and then if you come down here, integrated circuit is U. Seems good. We'll let it just be. We'll just leave it as an IC, and everything else is good. Hit OK. Now, as far as size goes, I'm going to zoom out. Whoa, holy mackerel. We're going to zoom out a little bit, and we'll move these letters around a touch. M to move. Move that up and out here. So you're like, well, how big should I make this? Well, it's not a footprint. It's not a PCB footprint, so we can make it as big as we want. But you can kind of get an idea how big this is going to be from the words. But really, when you go to put a pin out here, you're going to see you can't really change the size of the pins, not as far as I know. So you'd come out here and you place a pin, and here we'll just put it out here. So that's the size of a pin, and we need what, 12 or something like that? Where's my Mine. There it is. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 pins. What? That's not symmetrical. So we got 11 pins. So you're going to have to make this thing probably, about this big. It's a schematic, so you don't really want to mash your pins together super duper tight if you don't need to, okay? Should we make it the same as this? Yeah, why not? So, let's go for it. So we'll start moving things around. That seems good. Get this out of the way up here. So right now I'm editing input right here. It's listed as an electrical input. It's VIN. That seems to be okay for right now, but you might want to make it a power input, or if you don't care and you're tired of errors and things, because sometimes you're getting errors. Maybe it's a power input, but you just didn't want to put a power rail on it right now. You could just tell it that it is passive if you like. And sometimes it seems like there's been some glitches, and it seems to kind of where they go. We'll try power input right now. Name here is going to be VIN, pin number 1. Okay. And the direction right now is fine, but we'll change that for the others. And, oh, I guess I was making a new pin. Oops, get rid of that. Move that one up. Make sure all this is nice and clear. Again, don't cram pack everything so tight that you can't read it, which I might have done. We'll see. And next one, we have the enable low dropout. So the enable LDO, pin 2, and we'll just make all the rest here. We'll just make this be passive. Okay, that is the last one there. So that is, for the most part, our chip done. Now, take a look, see if it's good. The power input there, I've made everything else passive. The grounds would have been a power input too. If you aren't really concerned about your your design rules check, electrical rule check, sure, make them all passive, right? But if you want to make sure everything's working right, then go ahead and get all your pins in proper order. I'm going to leave that just as is, and then we'll go ahead and save this symbol. Look it over again. Then we'll get out. Come back here, and we should now be able to place the symbol because it will be in our library right there. All right. That is honestly the biggest part of this whole task that we're going to do today. Getting this symbol made, and then the rest of it is just bringing in the passives. All right, well, I wanted to jump in here from the future and explain what I meant about my little mistake there. So when I was making the footprint, I just kind of autopiloted it and just started naming them as their name, and I wasn't really, well, obviously thinking about the pin number themselves. So if you have the datasheet here, if you scroll down, just go down a little bit further, it's going to show you on here which pin number goes with which name. And more than just which name, this is how we're going to figure out which pin is actually on the chip. So, with all the chips, you got a dot that designates, pin 1. That's what we're looking at right here. So pin 1 is VIN. The next pin over is PG ground. The next one, or PG ground, power ground. The next one is power good, etc., etc., etc. By the way, there's the no connected pin that I was talking about. So there is a total of 12 pins on the chip. Okay, so make sure that you read this chart right here and make up your symbol correctly, okay? So that's going to be a little bit of work on your own. I was going to fix it, but at this point, it's just getting started in the video, and the chip, I'd have to redo the whole thing. So I figured I'll just jump in here, claim my mistake, and we'll move on. By the time we get to the next video, I'll fix the footprint. I'll fix the symbol. Now looking at the schematic here, I see 1, 2, 3, 4, 5 capacitors in here. I'm not worried about the values on them yet. So there's 5, but remember these are going to be 4, right? So we're going to have 8 total that we're going to bring out here, right? 4, 5, 6, 7, 8. Get that out of the way. And come over here, hit this, hit C for capacitor. There we go. That one seems just fine. So I'll put this one here. Hit C for copy, 2, 3. Okay, and then these 4 are going to be paralleled up as our output capacitors. Okay, good for now. Next, how about, resistors? So for resistors, we've got 2 right there. Symbol, R, resistor. One down here and one up here at the bootstrap. Then the last thing on here that I can see is an inductor. And we're going to have, of course, power in, power out. Deciding whether or not I want to do that with an actual power flag or not. Okay, let's go get an inductor. Inductor. There we go. Over here. So that is really it. Now we can start wiring the thing together. So we'll go and how about we'll take our VN and we'll run it over here. Just go like that. And then couple of that. And now this is all going to go to power ground. So you can do a ground flag symbol if you like and have them all be ground if they're getting in the way, or you can go ahead and run power ground to everything, you know, that you see over here. You can just like maybe you take this down, run it down along the bottom, seems to be pretty much protocol, and then just connect everything to that if you like, right? If of course your schematics start getting a lot more hectic, then of course use your flags. What the heck, let's put a flag in. So how about we say GND? So we have a few different ones here. Earth ground, this ground. You do something like that if you like. And then I'll hover here. You can hit W for wire, but it's going to start wherever you click. So if you do that, make sure you're right smack on top of it. And come out of now. I'm putting this in because it shows it, but I'm not even using the low dropout, but just in case you might want to, go ahead and add that in, and I'll copy this over here, wire that thing up there. So we got this guy, M to move, R to rotate. Put this right somewhere between PG and VCC. Wire that. And this guy here. Let's move this in line with that mess. Get right over the top. Wire. Connect. Okay. By the way, should probably come up here and hit save every so often, just in case. Continue on over here. So our PG and AG, we're just going to just join our grounds together. We'll copy that. Bring another one over here. So how about we just loop this in, bring this over, and V out. Let's do everything just how they got it here. So we'll grab this whole block, and we can just move this out a little bit over here. Let's get the inductor in line with the switch just to make things clean, right? And get over the top of 10 and hit W for wire. And then our V out. Get it. Actually, here, let's run the wire over here first. Whoa. Double click to stop it. Then bring our V out here on the other side of the inductor. And then we can start wiring up our bypass caps. So I want this, I'm going to scoot these up just a little bit. I guess I could just put them right in there. Yeah, and just let them tie together. That's kind of nice. That didn't used to happen, by the way. You used to have to come by and add junctions afterwards. Pre-5, I believe. Bring this up. I'd rather have it start over here, I think. Yeah, let's do that. And I think instead, I'll just bring this one out here and then down. I think I like the look of this better. There, let's stick that there. Okay. Ooh, forgot this. Forgot the bootstrap. R to rotate. Wire. This is getting kind of cramped. Nah, it's okay. Whoa. W for wire. Okay. There. That's pretty much it. Now I would like to put some power flags on here. So I want to have a V in and a V out. But think about it, you know, do you actually want to call it V in? Power, what do you name them, right? Now I think what I'm going to do is, oh, by the way, I sort of did it stupidly earlier. Here's our power flag symbol right here. So that's easy enough to just put that there, and it'll come up with all of these. Now, I mean, really, I could just leave this thing blank, but because I made VIN be a power input, it's going to require something to drive it. You're going to get this error that you might have seen, the dreaded, there's pins connected, but there's nothing to drive it, right? So I'm going to need to put something here. And in lieu of just not really kind of knowing what I want, I don't know what voltage is going to go to this exactly. It might be a battery, but it might be a separate power source. I kind of thought about that, and nothing negative for sure. So if you scroll down here, we'll just throw a power flag on it, and that will drive the pin. But the other thing, though, is I want to give a net name to this just out of convenience there. So we're going to call this... now, by the way, I could have done a VCC, but that's already being used, and so I didn't want to cause any confusion there. So we'll call this VIN as a net name right there, and so that'll be tidy. And in the course of doing this, I noticed you probably saw this already, but I forgot to ground right there. You've probably been yelling at the screen the whole time. So we'll go ahead and copy one of those. I don't really like to stick it right to it. I seem to like to have a wire there. You might even have to have that, but I don't know. There. Okay. And let's see. And then over here, again, I don't need anything there, but kind of like putting a period on a sentence or something. Well, okay, I guess some people would say that's the thing you're supposed to do. I'm going to go ahead and put a power flag there as well. And I'm going to name this net. Now, again, this is like I was saying, it could be 5 volts, but I'm just going to call it V out. So for right now, it matches to some degree the actual application circuit. And okay, so then I think we're good. The last thing we got to do is, if you look around, we got C question mark, C question mark. We haven't done any annotation. Nothing's been annotated yet. If you want to name things in some particular order, go ahead and name them by hand. So you just get into here and find the value, hover over it, hit edit, and then you can change it. But I don't really care what these things are named right now. So if you go to annotation up there and just say, do it for me, hit annotate, and now everything gets a number. U1, R2, C4, etc. All is good. Now, you can't run your electrical rules check until you've annotated, okay? So now that that's done, I can hit this, and then you can hit run, and then we could see what kind of problems we got, okay? So I've got a few flags here. Oh, my ground pin is pissed off. Okay, so we'll have to check that one out. And so the LDO we're not using. So that one's easy. We can fix this. The enable, we're going to put a voltage divider there. And I kind of want to talk about it in a second. So for right now, I'm going to go here. You come over here to the X, and on any pin you're not using, of course you could edit the footprint, but you might want this for something else and want to use that low dropout. So I don't want to edit the footprint and disable that pin. You just put a little X on it, and that's going to solve that problem. For right now, I'm going to put an X on the enable as well. And let's see what's wrong with this guy. Oh, let's by the way, just to clean things up, go back here to electrical rules check, delete the markers, run them again, and you see that you fixed it. So that fixed that. That's kind of a no big deal right there. And now we can read this here. Pin connected some other pins, but no pin to drive it. Oh my goodness. Okay, so we're going to have to put a power pin in here or something, okay? So before I get to just directly solving the problem, I want to show you this. So if, again, here, if I'll run the rules, electrical rule check, and it, wow, okay. So I went through, I changed a couple things, but it's still the same as it was, but now it bounces over here. But this is kind of okay, because this is what I wanted to show you. It's saying that this one here is broken. It has no pin to drive it. It is telling you that it's the pin 1 power input of that component, okay? It's telling you specifically that it's that, so that's at least something, right? So we'll go ahead and how about we delete the markers, we'll close this. Now watch this. So I'll just get rid of that. So let's say you're trying to solve the problem. You're like, oh, what is this thing? Is it the ground? Is it the capacitor? Is it the device? Did I leave something weird? Did I make it a power input or something? I didn't think about it. So yeah, let's just go ahead and delete it. So that should solve the problem, right? So we'll hit this. We'll say, go ahead, do it. Great. Wait, something else is, but no pin to drive it. Okay, so we need something for that guy as well. Okay, well, and also the pin's not connected. And you go through here and you'll do this. I mean, you could end up, yeah, we can always hit undo. What the hell? We get rid of that. And then we hit design rule check again. And you hit run. And no pin to connect it. Okay, but it's gone. What are you talking about? It's, oh, wait, it's this one down here now, right? And so if you keep going through this, you might run into this. You're trying to troubleshoot something, trying to fix it, and then you think you solve it, but it just bounced. Then if I got rid of this one, it'd go up here, and then it'd bounce, and then all of a sudden it'd go somewhere else, It's going to bounce to every single one of the grounds, okay? So here, I'll delete that, close that, and we'll get this back. The problem is, this right here, this input that we had here, and this pin that was a power pin that needed to be driven, because I made that a power input, needed to have a power flag on it, okay? And so I put the VA in. This one over here was fine. I just did that just because and labeled it. So that has nothing to do with this. But the ground is still a power pin, and it needs to be labeled as such. And you could do a couple different things. I could put another power flag, and I could stick it somewhere around. Probably I could just stick it here on this one, but that almost doesn't make sense. So kind of what a good... Maybe a habit to do is like this is VIN. You might put a here. Let me just show you with the ground. I'll do the ground here. It's almost kind of like a legend of sorts. Let's just copy this one here. We'll copy this. We'll bring it up here, and then we'll copy this ground and we'll put it right here, and we'll bring this together and we'll wire these two together. So now we're saying ground is a power pin. It's kind of a way of saying, hey, it's driven now, okay? So don't believe me? Here, let's go here and we'll run it, and looky, all works fine. Now, what you might do too is even though some things are already done for you here, you might go so far as to say, like say we had a battery input power flag and it was battery input power flag and it was battery output over here or something like that. You might label that all right here. So anything, it's kind of like seeing all your nets right here up in a legend in the corner, okay? We're just going to leave it like that, and that is good. Everything is all happy, and now we can save it. All right, so in the vein of trying to keep things short, I'm going to do one more thing here and then wrap this up. Things we have left to do, we still have to put the actual values on all the components here, so maybe you can do that on your own. Maybe that's a little bit of homework. How about that? But we also then need to associate all these with PCB footprints, and that part's the always the tough part. So, and the reason it's tough, you just got to associate with a footprint, right? Well, what footprint? The one for this chip. Where's that chip? We don't have it in the library. We got to go make it. So we got to go make it. But how are we going to make it? Because we don't know what it is. Oh gosh, we're going to have to go to the data sheet over here, and we're going to have to scroll down here somewhere, and we're going to have to find the dimensions of the thing and make our footprint for every single item that is not the cookie cutter jelly bean stuff, right? I mean, if we got an 0805 resistor or any kind of a pad in there, sure, that's going to work for these, right? But we're going to have to make up some of that. So for now, the last thing I want to do though is deal with this enable pin. So this enable pin is essentially an op amp inside here, and we need to give it a voltage reference to turn it on. We got to turn it on, put it that way. So let me show you here. Somewhere there is my little block diagram. Boop, 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 up, 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 up. And it shows you exactly how to do this, which is great. Right here, right? So here is your little EN comparator of sorts. But we're basically, like it says further up here somewhere, it says if you want to turn this thing on, we've got to give it at least 2 volts at like 5 micro, not microamp. So like no, typical op amp stuff, you don't need any kind of current flowing through it. It just needs to sense it that it's on, okay? And so we're going to do this with a couple 2 meg-ish ohm resistors. We'll do some calculations of that later, but right now I just want to get all of the players in order here, right? So we're going to make our voltage divider right here. So go to your component. We'll add, oh, what am I doing? We'll just copy this resistor right here. Put this here, rotate it around. And I need to get that pin right there. This is kind of tight. So I'll put one here and we'll copy another one and just sort of throw it down in here. And wire this to there. Wire this to here. And this pin right over to there. And then come over the top of this, hit delete, and it'll ask you which thing did you want to get rid of. I want to get rid of the no connect, so that one's solved there. And then this here, we'll copy this ground, paste it right there, zoom in, W for wire, click it right there. All right, so there's our divider done. This is going to get the sense the proper voltage, it will turn on. Now that's a thing to read in the data sheet, because if you want the switcher this to function, it says you need to have that enable pin on, okay? And one method to do that they recommend in the picture I just showed you there was to create the voltage divider, okay? So I think that is it. I'm pretty sure there's some problems here and there. I'm not exactly 100% on the divider and getting the enable to function, but we'll work that out and we'll go through the particulars in the data sheet as we get to making the footprints. I figured that was a good time to do that rather than just, you know, ramble about everything right now, because when we start to build our footprints and make associations to them and start hooking them up to pins, then we can go back through the data sheet and kind of talk about a little bit on what it appears that these things are all supposed to be doing, and maybe even take a look at the logical block diagram to see how the guts are working internally, okay? But this is good for now. So go ahead and start building this, and go ahead and name the things, and I'll get started on the next video, all right?